State and prove the principle of least action. Statement: if action A integral t1 to t2 sigma j pj qj dot dt is defined for a mechanical system, then the principle of least action for the conservative system is equal to delta A is equal to 0. Proof: since A is equal to integral t1 to t2 sigma j pj qj dt, which is equal to integral t1 to t2 bracket starts L plus h bracket close dt, which is equal to integral t1 to t2 L dt plus integral t1 to t2 h dt, which is equal to integral t1 to t2 L dt plus h integral t1 to t2 dt, which is equal to L integral t1 to t2 L dt plus h bracket starts t2 minus t1 bracket close. This is equation 1. Since h is a conserved, therefore delta A is equal to delta t1 to t2 L dt plus h delta bracket starts t2 minus t1 bracket close, which is equal to delta in integral t1 to t2 L dt plus square bracket starts L delta t square bracket close t1 to t2 is 2. Now we shall solve the integral of delta integral t1 to t2 L dt. Since t1 to t2 limits are also subject to change, in the variation of delta cannot be taken inside the integral. So let integral t1 to t2 L dt is equal to I, which implies I dot is equal to L, since delta is equal to delta plus delta t do dt, then therefore we have delta I is equal to delta I plus I dot delta t, because delta qj is equal to delta qj plus qj dot delta t is delta is equal to delta plus delta t d over dt square bracket close, which implies delta t1 to t2 L dt is equal to delta t1 to t2 L dt plus square bracket starts L delta t square bracket close t1 to t2. This is equation 3. Using the 2 and 3 we get delta A is equal to delta t1 to t2 L dt plus square bracket starts L dt square bracket close t1 to t2 plus square bracket starts h into delta t d square bracket close t1 to t2. This is equation 4. Clearly the terms of delta t1 to t2 L dt cannot be 0 in the consequence of Hamiltonian principle. Hamilton's principle requires that delta qj is 0 at the endpoints of the path, but in the variation of delta qj is 0 at the endpoints is not delta qj. Using the nature of delta variation, the integral can be expressed as delta integral t1 to t2 L dt is equal to integral t1 to t2 t1 to sigma j bracket starts del L upon del qj delta qj plus del L over del qj dot delta qj dot bracket close dt. Equation 5, integral which is equal to t1 to t2 sigma j square bracket starts d over dt bracket starts del L upon del qj dot bracket close delta qj plus del L upon del Qj dot d over dt bracket starts delta Qj bracket close square bracket close dt is 6 after the putting of delta L upon del Qj is equal to d over dt bracket starts del L upon del Qj bracket close from the Lagrange's equation of motion that implies delta is equal to integral t1 to t2 L dt is equal to sigma t1 to t2 sigma j square bracket starts d over dt bracket starts del upon del qj delta qj bracket close square bracket close dt but delta qj is equal to delta qj minus qj dot delta dt, so we have delta integral t1 to t2 L dt is equal to integral t1 to t2 sigma j square bracket starts d over dt bracket starts del L upon del qj delta qj minus del L upon del qj dot delta t bracket close square bracket close dt is equals to sigma j square bracket starts del L upon del qj delta qj minus del L upon del qj dot delta t square bracket close t1 to t2 since the end points delta qj is 0, therefore we have delta t1 to t2 L dt is equal to sigma j square bracket starts del L upon del qj dot qj dot delta dt delta t square bracket close t1 to t2 is equal to sigma minus sigma j square bracket starts pj qj dot delta t square bracket close t1 to t2 because del L upon del qj dot is equal to pj square bracket close putting this in 4 we get delta a is equal to minus sigma j square bracket starts pj qj dot delta t square bracket close t1 to t2 plus bracket starts L dt delta t square bracket close t1 to t2 plus square bracket start h delta t square bracket close t1 to t2 is equal to square bracket starts starts h plus L minus sigma j pj qj dot bracket close delta t square bracket close t1 to t2 is equal to, since h plus L is equal to sigma j pj qj dot, so thus delta a is equal to delta t1 to t2 sigma j pj qj dot dt is equal to 0, which proves the principle of least action.